Welcome to this explainer. Today, we're going to absolutely shatter the illusion that satellite imagery is exclusively locked behind massive corporate paywalls, or that you need some kind of PhD in geospatial science just to access it. For decades, the assumption has been that looking down at our planet in high detail is a privilege reserved strictly for governments and billion-dollar companies. But today, we're going to unpack the reality of the open-source eye in the sky. So let's dive right in. Can you actually see your house from space for free? Or monitor your local environment? Or maybe even find a lost pet using decades of freely available Earth observation data? It's a question millions of people type into search engines every single day, and the answer is this really fascinating mix of incredible technological access and, well, hard physics limitations. To figure that out, here's our roadmap for today. 1. Space data for everyone. 2. The free imagery heavyweights. 3. Specialized and disaster data. 4. Platforms that make it easy. And finally, 5. The limits of free data. All right, starting off with Section 1, space data for everyone. You know, the sheer scale of what governments and research institutions have just quietly made available to the public over the last few decades is honestly astounding. The big takeaway here is that anyone, literally anyone, with a web browser can now tap into a massive universe of free Earth observation data. We're talking about terabytes of information uploaded every single day. Whether you're working in agriculture, insurance, logistics, or honestly, if you just have a simple curiosity about how your neighborhood has changed over the years, the data is just sitting there waiting for you. The secret isn't paying for it. The secret is just knowing exactly where to look. Moving right along to Section 2, the free imagery heavyweights. Let's break down these massive government programs by what they do best. Here are your heavyweights cleanly contrasted. If you're looking for crisp, frequent updates, the European Space Agency's Sentinel-2 is totally your go-to, offering global coverage that refreshes every few days at a 10-meter resolution. But hey, if you want to see how a coastline or a city has evolved over decades, the USGS Landsat program is basically your personal time machine, all the way back to 1972. And if you need to see massive weather systems or wildfire smoke unfolding right now, today, NASA gives you that daily global picture, albeit at a much coarser resolution. Now, here's a really crucial distinction you've got to understand when accessing this data: optical versus radar imagery. Optical imagery, like what you get from Sentinel-2, gives you those gorgeous natural color pictures. But, and it's a big but, it gets completely blocked by clouds and darkness. On the flip side, we have synthetic aperture radar, or SAR, from satellites like Sentinel-1. These actually shoot radar pulses that see right through bad weather, thick smoke, and the pitch black of night. You won't get a standard pretty photograph for sure, but you will get critical data when visibility is practically zero. Next up, Section 3, specialized and disaster data. Sometimes standard monitoring just doesn't cut it. During natural disasters, the entire playbook for free data changes. Commercial giants like Maxar run these incredible open data programs. When a major hurricane, wildfire, flood, or earthquake strikes, they actually release their ultra-expensive, super high-resolution commercial imagery directly into the public domain under a Creative Commons license. This means first responders, researchers, and even the general public can assess staging areas and structural damage with unbelievable clarity when it matters the most. And when it comes to targeted environmental action, check out specific government initiatives like the NICFI program. Get this. Norway actually pledged 3 billion Norwegian krone a year to partner with commercial satellite operators like Planet and Airbus. Why? To provide incredible, completely free, high-resolution satellite-based maps of the world's tropics. We're talking under 5 meters in resolution, specifically to help combat deforestation, conserve biodiversity, and literally save tropical forests. Now, if your focus is strictly on the coastlines and the oceans, NOAA is an absolute goldmine. Through specialized platforms like their Data Access Viewer and Digital Coast, you can track sea surface temperatures, atmospheric conditions, and you can even download highly detailed LiDAR elevation models for coastal regions. All right, let's jump into Section 4, platforms that make it easy. Okay, so you might be hearing all these acronyms, USGS, ESA, NOAA, and thinking, great, but do I need a PhD in geospatial science to actually download and process this stuff? Thankfully, no way. There are these brilliant translators out there that make it incredibly accessible. Aggregator platforms like Skyfi, LandViewer, and the new Copernicus browser pull all this fragmented, complex, raw scientific data into one single place. They do all the heavy lifting of processing the files, so you don't need clunky desktop software. They literally deliver view-ready images straight to your web browser. Getting your hands on this data is pretty much as easy as using a standard map app on your phone. Step 1, you just set your area of interest by drawing a box on the map. Step 2, you filter by your desired date range and, this is key, tell the system to filter out days with heavy cloud cover. And Step 3, you just hit download or use their built-in tools to analyze the image right there on your screen. And why does this matter? Well, because real businesses and professionals use these exact same free workflows every single day. We're talking farmers using near-infrared bands from free Sentinel data to track crop irrigation and health across entire seasons. Insurance adjusters verify broad storm damage before ever putting someone in a truck to visit a site. Energy operators monitor remote pipeline routes. And get this, archaeologists even use these free platforms to hunt for ancient structures and graves hidden right there in the landscape. Which brings us to our final part, Section 5, the limits of free data. Okay, before we get completely carried away with the magic of open source space tech, let's talk about the ultimate catch. And that catch is resolution. The absolute best free optical data you can reliably get, like Sentinel-2, is 10-meter resolution. That means a single pixel on your screen represents a 10 by 10 meters square on the ground. That's roughly the size of a large building. Meanwhile, paid commercial data from providers like Vontor or Airbus offers 30-centimeter resolution, where a single pixel is basically the size of a license plate. So sure, you can track a massive flood, map deforestation, or monitor regional crop health for free, which is amazing. But there's a hard ceiling here. You absolutely cannot read license plates. You can't count individual cars in a parking lot, and unfortunately, you cannot find a lost dog. Actually, a user from northern Norway posted on a GIS forum asking for satellite imagery to find their lost dog. And the reality is, even the most expensive commercial satellites can't do that effectively, let alone the free ones. The final limit? Control. You simply cannot task a free satellite. You are completely at the mercy of their fixed orbital schedules. You just have to wait for them to pass over your specific location, and if you're using optical data, you have to pray that a cloud isn't blocking your view at that exact moment. You definitely do not get an on-demand, live feed of the Earth. So what's the game plan here? The smartest strategy for anyone looking to use Earth observation data is to always start with the free heavyweights. Use Landsat and Sentinel for broad, continuous monitoring to spot trends or issues. Then, and only then, if you need absolute clarity, like, say, verifying the condition of a specific piece of equipment on a specific day, you transition to a platform to pay and task a high-resolution commercial satellite. The barrier to entry for space data has completely vanished. The archives are wide open, the platforms are super user-friendly, and all these insights are just sitting there waiting. So now that you know the truth about what's freely floating right above us, how are you going to use this incredible open source eye in the sky today?